online classes will continue till the 13th cycle. Then if university will open in January or December or in any month, what will happen then?
Um, that's a very good question, but technically, we don't know what is going to happen because we are asked to take the classes. We don't know what will happen if the classes are open. Then are we going to retake what we have taken
Yes,
already,
sir.
or we are going to continue what we have finished? But one thing is sure that you're going to sit for the class test and you have to finish the lab project very quickly, I guess, to finish the semester.
Sir, won't it be so much difficult for us, like facing all the class tests and the like our labs
Lab.
and doing all the lab reports, and at the same time we are attending our confusion classes. So, sir, already, sir, if we attend the class tests like throughout the week and lab once a week, still it
Hmm.
gets tough for us. So, like if we do like this, sir, it already gets messy.
What I can actually suggest to you right now, you don't have to worry about that because what is going on right now is very important. Stay safe. If you're safe, then you can actually attend the classes physically. Okay. So what we are saying that online classes are very important for you guys. You have to take notes. You have to keep copy of those. I don't know what is going to happen. Either we are going to retaking any classes or just finishing what we have done after that. But still, the safety is big issue. So that's why it doesn't matter how far does it actually take, how long does it take to open the classes. You don't have to worry. Just right now, don't think that much. That are we going to be taking those classes or are we going to uh, finish or wrap up the things after the classes? That's a different case. So that's the policymakers' theory, not mine, and that will be decided through the authority of the university. So I don't know what will happen, but right now, don't think that hard. Just attend your classes. You know, sometimes attending the classes is very, what can I say? Uh, makes you very happy. You know why? Because you cannot see physically your friends in the classroom, in the university. But now you can see your friends and you can talk to your friends once in the class, like by using the online portals. So, can you imagine that 180 students are talking to each other on online portal? I don't know how do you do that. I don't have Facebook and anything like that, but like different things. So this is actually a good way to see like how many of you are attending. Like I can see right now 103 students are attending the class. Uh, just a good thing to see. So I don't know how many of you, like 103 students, 100, like from your side, 103 friends all together discussing anything in the class, in an online meeting section. I don't think so you can do it. Anyway, so
Sir, actually, last confusion.
yes,
Sir,
yes.
actually, a lot of our friends are facing problems. So, like, as our authority already told, like, we can approach to our authority for helps or
Mhm.
at least make our problems sound to them. So, like, if anyone wants to, uh, like, let the authority know what their problem is going on, is there any procedure, like, is there anyone to whom we can talk, like they can talk, or any one of us?
I think very first thing you can discuss with your course advisor. That's what his duty. Like he is there, he or she is there to hear your concern. So first discuss it to your course advisor. Okay. Then see what advices he or she give. Then I think from there you can actually talk to your departmental head and so on. I think you should go step by step. Okay. So what we have done in the last class basically is actually just give an introductory like of your substance. And we have seen that there are a couple of points, triple point, critical point, and saturation vapor line, saturated liquid line, saturated mixture. And we have learned about the heat of sublimation, then latent heat of evaporation, latent heat of condensation, so and so. Now, today we will learn about using of very important chart that is called the property table. And this table will be very helpful for you till end, like if you're working in a facility like heating, ventilation, and function system, and and the boiler designing, everything. You should like this graph will be very important. Like this table will be very important for you, and that's why I'm going to show you that. But before that, I should first show you basically about some of the properties that we need to know. Someone of you actually yesterday, the last class, has asked uh, uh, about the specific properties, right? Someone will ask for specific properties. So, what is the board? What is the board?
স্যার কথা শুনতে পাচ্ছি না স্যার
No, I'm just looking at the board. I need the board, whiteboard. I'm just looking the menu bar. What is the menu bar? I'm just very fast using these ones. Like yes, last class was the first one. Now this is the third one I'm just using. So I'm just, sometimes I cannot find them myself. So I'm just looking for the board where I can just write my things to show you. Okay. I can find the board. Board. Does anyone know where I can find the board? The June whiteboard. I'm just looking for it. It should always be on top of the meeting, but I cannot find it.
স্যার আসসালামু আলাইকুম।
Walaikum salam.
স্যার আপনার স্ক্রিনের নিচে শেয়ার স্ক্রিন গেলে ওখানে স্যার তিনটা অপশন পাবেন। শেয়ার স্ক্রিন মানে যে স্ক্রিনটা আছে সেটা, পাশে হচ্ছে যে স্যার হোয়াইট বোর্ডের একটা অপশন থাকে।
Okay. So the share screen, if I start the share screen, that will give me the whiteboard option already, right?
জি স্যার, জি স্যার,
Okay. Thank you.
জি স্যার।
Thank you. Can you see this right now?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So specific properties like what we have discussed, like specific, right? Specific properties. We know that we have so the V, the capital V, we know that is for the total volume, and this is small with a specific volume. And we also know that the H, capital H, is for the specific enthalpy, and then small h for the capital is for total enthalpy and small h for the specific enthalpy. I'll go for discuss, like I'll discuss about the what does the specific means, just to show you what does mean, what is the symbol for what a property. Okay, and then we're going to have another one. U and small u. Capital U means total internal energy, and small u is actually specific internal energy. Now, I'll go one by one and show you like what does it mean. So first of all, about just can you? We one actually is doing drawing this one. Can you just remove it, please?
Sir, there's option in the toolbar, sir. You can see.
Okay. This is actually total volume. Okay.
Yes, sir.
This is actually specific volume. Now, what is specific volume? We have discussed about that. Specific volume is specific, any specific properties basically is any specific properties. The property per unit
Sir,
mass. Okay.
some of
And
us, sir,
yes,
আমাদের
yes.
কেউ আনমিউট করে রাখছে, তো ব্যাকগ্রাউন্ড মিউজিক বাজতেছে, কথা ক্লিয়ার না, মানে বোঝা যাচ্ছে না স্যার।
আমি অবশ্য শুনতে পাচ্ছি না, মাঝে মাঝে কিছু সাউন্ড আসতেছে।
Yes, sir.
জি স্যার, ডিস্টার্ব হচ্ছে স্যার।
স্যার আপনার কথা স্যার কেটে কেটে আসতেছে স্যার। স্যার আপনি স্যার লিখলে স্যার এটা মানে অনেকক্ষণ পর পর আসতেছে স্ক্রিনে।
জি স্যার, এই সমস্যাটা হচ্ছে স্যার।
And that will be due to the network connection anyway. Okay. That will be for the network connection. Now, anyway, that's how we have to proceed. We cannot actually, yeah, still that is for the network. Okay. So, the property, specific property, because any property per unit mass, that is called a specific property. The volume per unit mass is called specific volume. Okay. Now, that's why we can, if you write it, this is the unit for a specific volume. Do you know the property enthalpy? What does enthalpy mean? This is specific volume is gone.
Total
internal
heat
energy.
content. Total heat content.
Total heat content, that is called enthalpy.
Yes.
And specific enthalpy is equal to H. This is actually kilojoule per kilogram. This is called specific enthalpy. And anything like this, basically, per unit mass, any property per unit mass is basically, is specific property. Now we need when we see when we're going to see the property table, we'll see 4 different properties. I mean, sorry, six properties. So those are pressure, temperature, specific volume, specific enthalpy, specific internal energy, and specific entropy. Now U, that is called specific internal energy. This internal energy is basically the energy, the sum of the energies in molecular level. Like we know that any substance, they are actually consist of various molecules, and there are so many energies within that molecules. The sum or the total of those energies are called internal energy. And if we take this internal energy per unit mass, that is called specific internal energy. And then some of the examples of internal energies are, the molecular attractive force, electromotive force, electromagnetic force. These are actually within the molecular level. So these forces are will give us basically the total internal energy. And then in the per unit mass basis, we can get the specific internal energy. And entropy, that is S, these are this comes actually handy when we are going to study about the thermodynamic laws, especially the second law of thermodynamics. Second law of thermodynamics gives us an idea about entropy. And that's why we are not interested on this property. We will deal with only pressure P, temperature T, specific volume V, specific enthalpy H, and specific internal energy U. So these are the main concerns for our side, and other things that we need to know, that is X. That is quality of steam, X, the value of X, quality of steam. That means mass of vapor present in a mixture, mass of vapor present in mixture, that is called quality. So I'm going to share one of the uh, file also, I mean PDF document. You'll see there what I'm saying. See, can you see right now? But I'm showing the saturated liquid vapor mixture.
জি স্যার।
Yes, sir.
So the quality X, the ratio of the mass of vapor to the total mass of the mixture, and this should be within. You see, you can remember the dome on the right hand side, figure 331. You see on the right hand side, saturated liquid states or saturated liquid line, the green line. Okay, and on right hand side, after the critical point, saturated vapor states or saturated vapor line. And with this dome, that is the saturated mixture or saturation mixture. And the value of X lies within these two lines, including these two, saturated liquid line on the left and saturated vapor state or line on the right. Did you get that?
Yes, sir.
So what I'm saying, this line is a saturated liquid line, and this line saturated vapor line. Okay, and there's a top point. And you can see there is a critical point on top, the black spot. So from black spot to the left side is basically saturated liquid line. On the right hand side is saturated vapor line. And within this region, basically, this region is saturated mixture. And the value of X that we are saying, the X, sorry, the X, this lies within this dome. Okay, that's why this is called the quality of steam. How much vapor is present in that mixture? Because in most cases we need the quality, and quality is defined by the amount of water vapor present. Yes, Hanif. Who is Hanif driver? Who is Hanif driver? Is there anyone who actually has the profile name Hanif driver?
স্যার আমাদের প্রতিটা ক্লাসে বাইরে থেকে কেউ কিভাবে জানি ঢোকে স্যার ক্লাসে ডিস্টার্ব করে, আইডি হুটহাট করে আসতে থাকে এরকমের। তারপর স্যার ইমাজিন, আই এম রিপেন ভিডিও, তারপর বিভিন্ন ফোনের কোম্পানির নামে এগুলো স্যার ভিডিও আমাদের ডিস্টার্ব করে আর কি ক্লাসে ঢুকে।
So, as we are talking about the quality, now if you see the default definition of it, and the definition you can see here basically is the mass of vapor present in the total mixture. How much vapor is present in the total mixture? So that is quality. And the total means the mass of liquid present into the system in the mixture plus mass of vapor. So this is the definition of quality. What we need to know is this: quality X is equal to mass of vapor divided by total mass of the mixture. Okay.
Sir.
Yes.
Sir. কোন টপিকে কি টপিক পড়াচ্ছেন স্যার বুঝতে পারছি না, নেটের প্রবলেম ছিল এজন্য তখন বুঝতে পারিনি স্যার।
Oh, I've started about the pure substance properties and the pure substance.
স্যার এটা তো কিছুই বুঝলাম না, পরে কি বুঝতে পারবো?
স্যার আমি প্রথম থেকে কিছু ঠিকমতো শুনতে পারিনি, সব কেটে কেটে আসতেছে।
নেটের সমস্যা স্যার, ঢুকতেই পারছিলাম না স্যার।
No, that's what I know, but how if it's
কথা কেটে কেটে আসতেছে স্যার, বুঝতে পারছি।
So that is
voice is
স্যার
buffering
স্ক্রিনটাও
continuously.
ল্যাকিং করতেছে স্যার, স্ক্রিনটাও ল্যাকিং করতেছে মাঝে মাঝে।
পিডিএফ এ লেখাগুলো পড়া যাচ্ছে না।
জি স্যার, পিডিএফ পড়াগুলো স্যার ঝাপসা দেখা যাচ্ছে।
are you using the smartphone who are actually looking at the PDF files like lazy? Who said that you cannot read the PDF files? Are you using the smartphone?
Yes sir, we are using
smartphone.
Oh, and that's why basically you can. It's really hard.
Most of us are using mobile.
Sir, most of us do not have any laptop or PC, but
yeah,
and this is why we are using smartphone to attend the class.
Anyway, so I'll just show you in the board then, whiteboard. I think I have shown you one thing. The quality, right? That's what we have discussed about it. The quality of steam, X is equal to so this is the definition of quality. The mass of vapor present in the total mass. Now, who cannot actually understand what I am actually teaching? I'm not sure if you actually followed my first lecture. We have started the pure substance, and the pure substance is that such kind of substance which actually remains its chemical composition whenever it changes its phase. Like it doesn't change its chemical composition. An example is water. If it's a solid state, it is actually an ice. And at liquid state, it's water. And when it vaporizes, it's steam. But throughout the phase change process, it doesn't change its chemical composition. Like it remains as H2O throughout this phase change process. So that's why it's a pure substance. And whenever we actually discuss about a pure substance, we give an example of water in most cases. And also we have shown some, the graphs or figures that shows the how the phase change or pure substance looks like. So
Sir.
yes, yes.
Could you please
Repeat what you just said. I couldn't.
So this is basically a PV diagram of a pure substance, and this is on vertical axis is pressure and horizontal axis is volume, specific volume. Excuse me. Okay. Now, top point, like this is the topmost point. That is called the critical point.
স্যার স্ক্রিনে তো কিছু দেখা যায় না স্যার।
জি
স্যার
Sorry?
স্ক্রিনে প্রবলেম হচ্ছে স্যার। স্যার স্ক্রিনে কিছু দেখতে পাচ্ছি না স্যার, সাদা
স্ক্রিনে
হয়ে
তো
আছে,
দেখা যায় না
ব্লার হয়ে যাচ্ছে স্যার। হ্যালো
Hello, yes.
স্যার স্ক্রিন ঝাপসা দেখাচ্ছে স্যার।
জি স্যার, স্ক্রিন ঝাপসা দেখাচ্ছে।
It might be due to your
স্যার
network
আমি
connection.
কথা বলতে পারছি না।
স্যার আপনার কথাটাও আটকে আসতেছে স্যার, বেজে বেজে আসতেছে।
How can actually solve those issues? Because these are all up for the network connections. You can just attend the class.
স্যার
and
আমি
see.
স্যার ভালো নেটওয়ার্কের জন্য স্যার বারান্দায় এসে ক্লাস করতেছি স্যার।
That's good.
স্যার এরপর আর কি করতে পারি স্যার?
What can I do from your side, from my side? What can I do from my side?
স্যার বুঝতেছি না স্যার, কথা আসতেছে না ভালো করে স্যার।
Sir, I think you should continue. Sir, I think you should continue because it's drizzling here in Dhaka and I can see everything visible and audible here.
No, it's drizzling here as well. It's raining in Russia as well.
Sir.
Yeah.
Sir, even after that, it's visible and audible to me, sir.
Okay.
So I think you should continue.
It's visible and audible, sir.
It's okay.
স্যার আমরা সবাই তো ঢাকায় থাকি না স্যার, আমাদের তো সমস্যা হচ্ছে।
No, that's I know that. What I'm saying, like, I anyway, I cannot actually solve individual case, right? I can give you the lecture, you follow it, and I'll give it to the department, and they will actually do whatever they can do with this recording. Okay. It will be given by the department. I cannot give it to you. That's what we have actually. That's the decision from the department. They'll upload it by themselves. Okay. So yes, Jim.
Sorry, sir. It was a mistake.
Okay. So on left hand side from the red the saturated liquid line, and right is saturated vapor line. This is saturated vapor line. This is saturated liquid line. And we have discussed about the X quality of steam is basically lies within this dome. This is called the saturated mixture zone. So when we are in a saturated mixture zone, there should be two different states present in the same time: a liquid state and a vapor state. That's why this is the quality of X, or the quality of steam. X comes in play. And this is important when you're designing the boiler system as well. So now we're going to see an example, and then we'll see about how to use the property table. How to use the property table. Yeah. Usually, I give this example from St. John's textbook, example 3.9. Okay. Can you see this? So determine the missing properties and the phase descriptions in the following table for water.
Yes, sir.
Even though I know like someone is using the smartphones, many of you are using smartphones. Okay, is it visible?
Yes, sir.
Yes, sir, it is.
Now, you see this, the treble T, P, U, X, and then phase description. The phase description means what is the state of the phase when we are getting the properties. Okay. And one thing I have forgot to mention, that the value of X, as we see that this lies within the saturated liquid line and saturated vapor line. Value of X lies so 0 to 1. 0 is the saturated liquid, 1 is saturated vapor. Okay, when we are having the value of X is equal to 0, that means the point is on saturated liquid. That means upon getting more heat, it will become saturated mixture. Yes, Haka. Who is Haka? Okay. And when we are having the value X equal to 1, that is saturated vapor. All the liquid particles present in the mixture becomes vapor. And upon getting more heat from the system, it will become superheated vapor. So on the left hand side, of the dome that we have shown already, that is compressed liquid, then line saturated liquid line, saturated mixture, saturated vapor line, and then superheated vapor. So this is basically a critical point. And left hand side, this is saturated liquid line, and this is saturated vapor line, and this region is compressed liquid. Compressed liquid, and this zone on right hand side of saturated vapor line is superheated. Vapor. So this region is compressed liquid and this region is superheated vapor. And we see this saturated liquid line, and this is saturated vapor line. And this is mixture, saturated mixture. Okay. So property table, we are going to see right now, there are 5 different property tables. So I'm going to share the property table right now. So you see this superheated, the tables started with table A4. There are 3 more tables ahead of it, A1, A2, A3. And this is also one thing I need to show you, that this is actually based on the SI unit. This is based on the SI unit. And this is temperature on leftmost column, temperature, pressure, so this is temperature based table. Now in thermodynamics or in the chemical engineering, whatever you are actually dealing with the heat, temperature is the most important property. And we have to look at the properties mainly based on based on temperature, then based on other. But the most important property in thermodynamics is the temperature.
স্যার লেখাগুলো অনেক ছোট আসছে, একটু জুম করলে ভালো হইতো স্যার।
আমার তো স্যার দেখাও যায় না, মানে আমারই প্রবলেম নাকি স্যার সবার প্রবলেম বুঝতেছি না, কিছুই তো বুঝতে পারছি না।
So this
সবারই
is
প্রবলেম,
table A4. This is based on temperature. I have mentioned that there are 4 different property tables. Table A4 for temperature, based on temperature. The based on temperature means the leftmost column. The leftmost column is based on temperature. The leftmost column. You see the first property tabulated on the leftmost column is the temperature. Okay. Now it continues to the next page. Table A4 continued. And then we are having table A5. This is based on pressure. Based on pressure. On the leftmost column, then we are going to have the pressure, then the corresponding saturation temperature. On the previous table, we have seen the temperature on leftmost column and then the corresponding saturation pressure. But in pressure-based table, the leftmost column will be for the pressure, and the next column on its right will be for the saturation temperature. on that given pressure. Okay. Any questions so far for like the table, body table?
স্যার আরেকবার একটু বোঝাই দিন। So
So what we are so what we are saying basically, there are 4 property tables for the water only. So the first table, what we are saying basically, table A4, that is based on temperature. The leftmost column will be table temperature, and the next column to its right on temperature will be saturation pressure corresponding to this temperature. You see this, the first point is given, the temperature is 0.01 degrees Celsius and its corresponding saturation pressure is 0.6117. That means at 0.01 degrees Celsius, the saturation pressure for temperature is 0.6, or saturation pressure for water is 0.6117, and so on till the end of the temperature table. And the final temperature is, as we discussed as well, is the critical temperature 373.95 degrees Celsius, which is having the corresponding pressure of 22.064 megapascal, or it's in bar kilopascal, 22,064 kilopascal. The next table is based on the pressure, as the title says, saturated water pressure table, and this is the leftmost column heading pressure P at kilopascal, and then the rightmost column, the next column to its right is saturation temperature. So if we see this at pressure 1 kilopascal, the saturation temperature is 6.97 degree Celsius. The saturation temperature is 6.97 degree Celsius. Okay, and so on till the bottom of the end of the table. And the final temperature pressure is given 22.064 megapascal, or 22,064 kilopascal, and its corresponding temperature is 373.95 degree Celsius, and the corresponding properties are given to the right hand side. Now, these two property tables, table A4 and A5, has some similarities, and the next two tables are different. However, these are also for the water. Table A6, this is for superheated water. That means, if we recall the dome-shaped figure, and we see that on the right, the line of the critical point. On the right hand side, we are having the saturated vapor line. Beyond that saturated vapor line, or on the right side of the saturated vapor line, is the superheated water region. And this property table A6, only for that superheated water. So we have many tables for superheated water, like sub-tables, because on the left column of each and every superheated water table is saturation temperature, and then on the top of the table you see this, the pressure is tabulated on based on pressure as well. So temperature and pressure, there are actually 3 pages for this, I guess. This is the final 4 or 5 pages, and final is 60 megapascal. And when you see this on the left hand side, still the temperature. Okay, the saturation temperature, T Celsius. And then table A7, the final table. This is compressed liquid water. That means the left part of the saturated liquid line. If you recall the saturated liquid line of the dome, on the left hand side of the critical point, that line is saturated liquid line, and the region on the left side of the saturated liquid line is basically a compressed liquid water, and it starts at 5 megapascal pressure. That means 5000 kilopascal. 5000 kilopascal. Okay, so this is basically the 4 different, property tables and charts, the property table that we need for water. There are more tables after that, saturated ice water vapor, or so many things after that, but these 4 tables are very important when we are actually dealing with the properties of water, of water mixture. And as I said, that table 4 and table A4 and table A5 has the similarities in terms of properties. See this? I'm just going to table A4. Now here. There are 4, as I mentioned, there are 4 different properties are tabulated. Specific volume, internal energy, enthalpy, and then the rightmost column we are having the specific entropy. Can you see that? Entropy on the right hand side, enthalpy, then the internal energy, then specific volume. So can you see that?
Yes, sir.
Okay. Excuse me. This property table you can download it from online. It's actually available online. You can download from online this specific property line. You can download it. This is the property table in SI unit. Essentials textbook, SI unit. The property table. You can download it. And as you say that appendix 1 SI units. So 4 different properties: specific volume, internal energy, enthalpy, and entropy. And as I mentioned earlier, that entropy is actually due to the second law of thermodynamics. Okay, so we are not actually now dealing with entropy right now. We'll discuss about the other 3 properties: specific volume, internal energy, and enthalpy. And one interesting thing about specific volume is, if you see the unit of specific volume, what is mentioned here is meters cube per kilogram, right? So the unit of specific volume is meter cube per kilogram. Is it?
Yes, sir.
So that means this is the inverse of density. You know the unit of density is kilogram per meter cube, right?
Yes, sir. kg per meter cube.
So that means the unit of specific volume is meter cube per kilogram and unit of density is kilogram per meter cube. That means inverse of density is the specific volume or vice versa. The inverse of
Yes, sir.
inverse of specific volume is the density of that substance. Okay. Now there are some other properties also mentioned. I'm just zooming it more. V suffix F, V suffix G, U suffix F, U suffix FG, UG, HF, HFG, and HG. I'm not going to the entropy part because that's already in there. Okay. SF, SFG, SG. So the suffixes, what do they mean? UF, UFG, and then UG. So the suffix F is for the liquid portion. We said that this is for the mixture, right? So U suffix F is for the liquid portion. U suffix FG is for the liquid to the gas. Liquid to gas, the change of phase from liquid to gas. That means the change, like the evaporation. You see that saturated liquid, evaporation, saturated vapor. So UF means the saturated liquid part. UFG means the property suffix FG means the change of phase, and the G is for the gaseous part. Okay. Did you get that?
Yes, sir.
Yes, sir.
So U suffix.
কিছু শুনি না।
No, sir. Sir, I didn't understand a single part of this story. What should I do now, sir? Any suggestion, sir?
Session is actually discussed with the department, discussed with your course advisor, then department, and see what happens from there. Because
Okay.
I'll give this video to them. Okay.
Okay.
I'll give this video to the department, see what they can do with it. Now just follow. Like I can see that the participants are actually decreased now. Now 84 participants are present in the class. Anyway, so any property, the suffix F, this is for the liquid portion. Suffix FG, that means change of phase from liquid to gas. And suffix G means the gaseous part. Suffix G means the vapor part. The vapor part. So now one thing, all other properties except the volume has the property for the phase change, but volume does not have, because volume either liquid or vapor. There is no intermediate part, but phase change from liquid to vapor. But all other properties like internal energy and the enthalpy, all of them has the phase change, and this is actually the one. And one thing that I can actually say that the phase change HFG, this evaporation in enthalpy, this is actually latent heat of evaporation. Latent heat of evaporation. Latent heat of evaporation. H suffix Fg. This is basically is latent heat of evaporation. Like you know that what I want to say. That means phase change from liquid to gas. This amount of heat is required for this temperature at 1 degree, so 0.101 degrees Celsius. 1 kg of water will require 25.9 kilojoule per kilogram of heat to convert from liquid to gas, and this is called latent heat of evaporation, that's HFG, and that's all we need. And we just say that uh, and that's what we need to use. All of this concept we need to use to solve uh, this example. We see this temperature column, there are some blank spots. The pressure table, there are some blank spots, black pressure column, the internal energy column, the column of X, and the phase description. And as we mentioned that X is the amount of vapor present in total mass of the mixture. So this portion, the value of X, we can actually, by seeing the value of X, we can actually describe the phase as well. Okay, so point 6, now we have discussed that how can we determine the X as well. One equation I have shown, X is equal to mass of vapor divided by the total mass of the system. Now, I just want to show one more thing. How can you also determine the value of X even though we don't know the specific masses or the liquid or vapor? So the equation is, there it is. So one thing about the property table, can you see the property table here still? One thing about the property table is, I can just is equal to, so the property is specific enthalpy of evaporation or latent evaporation, HF is equal to specific enthalpy at gaseous vapor state minus specific enthalpy at liquid state at the same temperature. This is actually, you can even though you don't know the value of Hg, you can actually get Hg and Hf, and difference of Hg and Hf will give us the Hfg. And another thing I need to actually share with you, the equations. So how can I determine the value of X as well? See, VFG, VG minus VF, and this is the value of X we can get as well. X equal to V average minus VF, here the VFG. VFG means you see that you can see the VFG here. I have mentioned only VF is VFG equal to the specific volume at gaseous state minus specific volume at liquid state. Vg minus VF will give the VFG. And the V average, that means if you are given the value of X and you know the temperature as well. Sorry, if you don't know the value of X, but you know the temperature and pressure. One thing you should know that if you want to use the property table, you should know at least two properties of the property table. You should know at least two properties. And if you know that, then actually you'll be able to get all the other properties from the property table. So the V average means we need to determine at a given temperature and pressure, the V average. So V average is equal to 1 minus XVF plus XVG, and which is basically this. V average is equal to VF plus XVFG. And if you actually rearrange the terms of this equation, you will end up with this by using this formula. VF is equal to VG minus VF. And finally, the value of X is equal to VFG minus VF over VFG. Like when you're going to solve the problem or example that I mentioned, you'll be able to understand. But right now, get the equations, and then we like to discuss. We're discussing right now, but in the next class, we'll actually solve the problem to see how can we actually determine the values. And similarly, these are the other two properties. We have seen that V average. Now we are seeing the U average and H average, internal energy average and specific enthalpy average. And you just see X. They are all incorporated with X. And property Fg, as I mentioned in the whiteboard, Fg is equal to G minus F. Okay. Any questions so far? Yeah, if I'm not actually getting into the lecture, I'll just give the video. Sorry? HF is for specific enthalpy at liquid state at given temperature and pressure. Okay, and H average is actually, you need to determine the property at the given temperature and pressure. That will be within the HM and HFG or HF or HG. Okay. We'll see when you're, yes.
Sir, is there any particular value of steam quality?
Yes, there is well. I said that the quality of X actually lies between 0 and 1. So lowest is
Sir,
0.
what does 0 rectify?
0 is equal to this is saturated liquid.
I mean, sir, the purest one.
Everything is pure. When you are talking about the water is a pure substance. Whether it is actually a mixture, whether it is actually either liquid state or gaseous state or solid state, it is actually a pure substance. It doesn't change its chemical composition.
Thank you, sir.
Welcome. So H average, that means at a given temperature and pressure, we need to determine the value of a mixture where we are giving this HF1, HFG and the value of X as well. If we know the value of X, then we can get the value of H average. Okay. Do you have any other question?
No, sir.
So What I am saying is basically. So this is actually chapter 3, the pure substance chapter 3. And the appendix are actually the appendix. It doesn't have any page number. Table A4, you go to table A4, that's it. But the chapter 3 is actually the textbook of Sendel. You can download it from online. It's a very big file, 83 megabyte. I cannot actually share it anyway. But you can just download it from online. You can get it by yourself. And I see that someone actually already have downloaded appendix by saying the chatting option of I can see this. So it's just okay. Just a
Sir,
second.
can I please ask you something out of the topic?
Just a second, Ryan. This is Afridi Hassan. He actually shared Appendix 1 updated metric 1.4. You can download it from this if you want. Yes, who is actually this? Want to
Sir,
talk to
it's
me?
me. Sir, actually, like whatever we are learning now in the final exam, like semester final, will it be up to what you have taught us, or like the whole syllabus given to us? It's like the exam will be upon just up to what you taught us, or the whole syllabus.
It should be on whole syllabus. The final exam for the whole syllabus. This is actually the part of your syllabus, okay?
So even if we can complete the whole of it in the class, still it will be the whole syllabus.
I don't think you'll not be able. I don't think that you'll be able to solve. Like we have, you like the teacher will somehow finish the syllabus. It doesn't matter to you. Like, but based on the syllabus. Any more question?
Sir, a request to you, please, sir. Like, as a lot of us are facing a lot of problems, so we also try to approach to our teachers or course advisors or some of other teachers. So, like, as we are the newbie here, so like the teachers are not. So, yeah, please don't take it like that.
No, I know,
Still,
understood.
the
Yeah.
teachers are not taking us like that. Like, we are telling our problems, but they're thinking like, yet we have to learn something else. They are not taking us that much seriously. So you are one of the senior teachers of our department. So if you just please let them understand like what we are facing, what what our students are facing, it will be a lot more convenient for us to make them understand.
Yes,
We
sir.
have.
Actually, if you inform this to the authority, it will be very much effective. Then we
Understood,
Sir, we
understood.
will
But
approach, sir. We will approach.
let,
But
let,
yet,
let,
yes, sir.
let me say something to you, all of you. Yeah, what you are saying actually, we have discussed all of those things in our several meetings already. But what we are asked, we have to take the classes and see what happens after that. Okay, that is the conclusion.
আর স্যার এখানে একটু পরপর বারবার কারেন্ট যাচ্ছে, সো আমি কনসেন্ট্রেট করার চেষ্টা করার পরও বারবার বের হয়ে যাওয়া লাগতেছে। এই প্রবলেমটার সলিউশন কি হতে পারে?
I cannot. I don't know. Like, are you using your cell phone or using a laptop?
এখন আমি ল্যাপটপ দিয়েই ঢোকা, কিন্তু কারেন্ট গেলে তো ওয়াইফাই এমনি চলে যাবে।
Oh, I don't have any solution for that. You know, I know. What can I say? Either you can. What you can do actually? Do you have UPS? Sorry, IPS.
ইয়েস স্যার, বাট ওয়াইফাই লাইন তো আইপিএস এর সাথে কানেক্ট করে না।
You can just connect your that plug through which that IP like Wi-Fi router is connect this plugs. You can actually connect IPS line with that plug. or that Wi-Fi only, because it doesn't consume that much energy. So you can actually connect it there. Then you will be able to have the continuous support from Wi-Fi. You can ask your some of the electricians. It's really hard right now, but you can do it. Anyway, any more question?
Sir, I have a question, sir.
Yes. Who is this?
Sir, I am Raihan.
Okay,
Sir,
okay,
can
okay.
you see me?
Yeah, I can see you. I can see you.
স্যার আপনি স্যার যদি দেখতে পারেন স্যার এই টার্মটা এখানে 6টা টার্ম আপনি দেখাইছিলেন এর ভিতরে এস দ্বারা স্যার কি মিন করতেছে এটা স্যার আমি বুঝতে পারি নাই
This is entropy, and I have mentioned that entropy S is for entropy, and entropy basically it comes from second law of thermodynamics, and since this is actually the higher part of it, we are not taking it right now. We'll discuss other 5 properties, not the entropy. Entropy means how haphazardly or the disturbance in a system. That is entropy, and this is related to the temperature. Excuse me. We'll actually discuss only pressure, temperature, specific volume, specific internal energy, and specific enthalpy, not specific entropy. Okay.
স্যার আমরা এক্ষেত্রে স্যার স্পেসিফিক ভলিউম এখানে রাখছি টার্মটা ভিতরে স্যার টোটাল ভলিউমটা সেখানে রাখা হয় না কেন?
Total volume. If you know the mass of the system, you will just multiply the mass with the specific volume. You'll get the total volume. Okay. So that's why this is really easy to determine the per unit mass in most cases. If you know the mass of the system, then you can actually get the total value of the property. That's why
Yes,
it's
sir.
actually this is designed for per unit mass.
স্যার তাহলে স্যার আমরা স্পেসিফিক প্রেসার যদি সেক্ষেত্রে নেওয়া
No,
হতো তাহলে
there is no specific pressure. So the properties, there are 2 things, like related to the mass, non-related to the mass. Pressure and temperature is not related to the mass. That's why they are actually not specific properties. The other properties are related to the mass. That's why they are specific properties.
Thank you, sir.
Any question? Now, the pure substance, as we discussed before, a pure substance means a substance which does not change its chemical composition when it changes its phase from one to the other, either from liquid to the gas or solid to the liquid. It remains.
Yes, sir.
It keeps its chemical composition as is. That is called the pure substance. That means water. It doesn't change its chemical composition. Since it doesn't, when it changes its phase from solid to liquid, liquid to gas, then it is a pure substance. Okay, when any substance changes chemical composition, you cannot say it a pure substance. But as long as it doesn't change its chemical composition, it is a pure substance. One thing, please don't share your what can I say, the meeting invitation to the other one. I think you're sharing it to the you are sharing it to your Facebook group, right?
Yes, sir.
Harish? Okay, so some of your friends are actually, I think, getting into it. I don't know whose. I can see one of them is James Bond 007. I don't know whose friends is, but I think he's also actually trying to get inside.
Yes, sir.
So please make sure that your friends are not like other than the REIT students, other than the REITian. Please don't allow them to get inside. I can actually do them, but if it's your friend, you should better know. You should do that, okay?
Yes.
Yes, sir.
Any question? Any more question? In the next class, I'll actually solve. I'll solve the problem, and we'll actually discuss it from there as well. Okay.
Yes, sir.
Yes, sir.
So, do you have any other question regarding to this class? Do you have any other question?
No, sir. Sir.
No, sir.
Okay. So the next week we'll try to solve the problem by like solve the example by yourself. Okay.
Yes, sir.
Okay. Thank you.
Assalamu alaikum.
Wa alaikum assalam.
Assalamu alaikum.